Alright, let's start 13.1 day 2 by reviewing the Pythagorean identities. The first one is pretty much just the Pythagorean theorem on the unit circle. If you picture the unit circle, pick a point. Well, we know that cosine is the x, sine is the y, and the hypotenuse is also the radius of the circle. So cosine is the x, we square that. Sine is the y, we square that. And the hypotenuse is 1 because the unit circle has a radius of 1, and if you square 1, that equals 1. Alright, for the next one, some people remember this as I tan by the c. So I tan by the c, and then both the tan and the c are squared. And the I is a 1. The trick to remember the last one is I by cots at Costco. So the I is a 1, and then cot is cotangent, but it's squared. And then Costco is the cosecant. So again, I by cots at Costco, I tan by the c, and I don't have a device for you to remember the first one. Okay, so for number 9, what jumps out at me is on the top, I see it looks a lot like I buy cots at Costco, but with some of the stuff moved around. So let me write the equation we're used to seeing. So we're used to seeing something like that, and if you just subtract this to the other side, then you have this. So the numerator looks like it's 1. And so a common technique that people use when simplifying these trig expressions is they try to turn everything into either sine or cosine or both. So what I would do here is tangent is also known as sine over cosine. And so if I do that, then these cosines in the numerator could both cancel out, and we're left with 1 over sine. And 1 over sine is cosecant. Okay, number 10 looks like our first Pythagorean identity. So I'll write that one. Sine squared theta plus cosine squared theta equals 1. And if you subtract this to the other side, we could tell that the numerator is just sine squared theta. And the next thing I notice is the numerator and the denominator both have sine theta. So if I cross this out, then I could cross out this square, so there's only 1 sine theta on top. So now it's sine theta. And remember that tangent is sine over cosine. And we know that when we divide by a fraction, that's the same as multiplying by the reciprocal. So now these sine thetas cancel out, and we're left with cosine theta. Okay, so again, a common technique is change everything to either sine or cosine. So secant is 1 over cosine. And if we multiply that together, we get sine theta over cosine theta. Sine over cosine is the same as tangent theta. Okay, cosecant, we know that's the reciprocal of sine, so this becomes 1 over sine theta times sine theta. So that one was pretty easy. That one is just 1 because the signs cancel out. Alright, so on number 13, I'm going to stick with the strategy we've been using of changing everything to sine or cosine. So tangent is sine over cosine. Cotangent is the reciprocal of that, so it's cosine over sine. And so in order to add fractions together, you need a common denominator. Here our common denominator would be cosine theta times sine theta. So the first fraction needs to be multiplied on the top and on the bottom by sine theta. The second fraction needs to be multiplied by cosine theta. And then the whole thing would be over cosine theta, sine theta. Okay, so again, I took this first fraction, I multiplied it by sine theta over sine theta. Then the second fraction, I multiplied it by cosine theta over cosine theta. Then I combined the numerators together. And remember, when you add fractions, you don't add the denominators together. You keep the common denominator the same. Alright, well, what did that do for us? The numerator is now 1. So we have 1 over cosine theta, sine theta. Okay, not sure why it got so blurry there. But anyways, the book considers this to be simplified. But I think it looks simpler if you write it without a denominator. So 1 over cosine is secant theta. 1 over sine is cosecant theta. So I would take both these answers. I actually prefer the one on the bottom. For number 14, we can change cosecant to 1 over sine. We can change tangent to sine over cosine. Tangent again is sine over cosine. And we could keep this last sign the same. Alright, so these can cancel out. It looks like 1 over cosine. 1 over cosine theta minus sine squared theta over cosine theta. And we already have common denominator, so we can combine the numerators together. Alright, the top looks like our first Pythagorean identity. So this one, cosine squared theta plus sine squared theta equals 1. If you move this to the other side, then you have 1 minus sine squared theta, which equals cosine squared theta, over cosine theta. So if I cross this out, and now there's only 1 left on top, so the final answer is cosine theta. Okay, 15, cosecant theta is 1 over sine theta. Cotangent is cosine theta over sine theta. Now we have a common denominator, so we can combine the numerators together. And there's really nothing else we can do with that, so this is considered simplified. Okay, for 16, we have the numerator is our first Pythagorean identity, so we know that's 1. And then on the bottom, we have our first Pythagorean identity again. So I'll just go back up here. If you take this and subtract that to the other side, then you have 1 minus cosine squared theta, which equals sine squared theta. So the denominator equals sine squared theta, and 1 over sine is cosecant, and since it's squared, that would be cosecant squared theta. Alright, let's finish up with a couple word problems. Alright, so I'm just going to read the bottom first. They want us to express that in terms of cosine theta only. Alright, so first thing I'm going to do is distribute. So what I have here is, so sine and cosecant are reciprocals of each other. So when I distribute this here, well, anytime you multiply something by its reciprocal, you get 1 as the product. And now distribute that one, you get sine squared theta. And there's our first Pythagorean identity again, which equals cosine squared theta. Okay, almost the same thing on the last one. So they want us to take this expression and put it in terms of cosecant theta t. They want us to express a in those terms, that is. So first thing we have to do is solve for a. So if I get a by itself, then I have y divided by sine theta t. But the directions say we want the answer in terms of cosecant theta t. So right now we have 1 times 1 over sine theta t. This equals cosecant theta t, and that's our last step. So replacing the part I circled with cosecant theta times t. And now we've solved for a and put it in terms of cosecant theta t. Okay, that's it for the second half of 13.